So pressure, volume, work. We talked about work being the exertion of a force through a distance. Work can also be caused by a volume changing against an external pressure. So when gases expand, the change in the volume is positive. But the system is doing work on the surroundings, and so W is negative. So we can say that, the pointer, there we go, work is equal to negative P delta V. The negative here is just to make the sign on the work correct. The pressure is going to be positive, the change in volume is going to be positive, and so we have to throw a negative sign in there. Here's an example. Here we have a gas in its initial state, and it expands, and when it does that, it pushes the plunger up, the piston up. It expands against a pressure, and so we see that the change in volume is positive, but it has done work on this piston. This is exactly the sort of work that happens inside the internal combustion engine. You have combustion inside, that's hence the name internal combustion, and it pushes the piston up. So work has units of joules. Pressure, we often use atmospheres, and volume is often liters. So there's a relationship between joules and atmosphere liters, and that's this guy right down here. 101.3 joules is equal to 1 atmosphere liter, or liter atmosphere. Now, I don't expect you to memorize that, but it helps if you remember that it exists, because otherwise you can get a little flummoxed by some of the unit conversions necessary. Okay, so a cylinder equipped with a piston expands against an external pressure of 1.58 atmospheres. If the initial volume is 0.485 liters and the final volume is 1.245 liters, how much work in joules is done? So we're asked for work in joules. So we're looking for W, and we're talking about a pressure and a change in volume. So we're going to use the equation W equals P times delta V. We got the negatives in there, and the pressure is 1.58 atmospheres. Now we need delta V. So delta V, delta is always final minus initial. So this is the final volume minus the initial volume. So that's going to be 1.245 liters minus 0.485 liters. .76 is what the calculator says. Both of these numbers had 3 decimal places. The 5 minus 5 is 0, and so there should be a 0 here. This number actually has 3 significant figures, and that's liters. So we plug the delta V in here, 0.760 liters. And we've got negative 1.58 times 0.76. Calculator says 1.2008. And what are the units on that? Atmosphere liters. But the question wants the answer in joules, because atmosphere liter is a weird unit for work. So we just need to do a little unit conversion. Oops, not equals. Times. So we want atmosphere liters on the bottom, and we want joules on top. And we go look this up. 101.3 joules is equal to 1 atmosphere liter. And so we do this math, and we get minus, oops, not 2 minuses, I already did that. 121.64 joules with 3 significant figures, so we would round that and say negative 122 joules. The work is negative because the gas did work on the system. Any questions?